Okay, so today we are going to start lesson 3, and today we're going to talk about hyperbolas. Now, I'm going to show you some key differences between this standard form and the ellipsis standard form. The first key difference is this standard form has a subtraction sign, where the ellipsis has a plus sign. The other key difference is the a squared is always going to be under the first fraction. So before, remember, the a squared and the b squared flip spots. Here, the a squared and the b squared stay in the same fraction. So the a squared is always under the first fraction. The b squared will always be under the second fraction. What's changing in this form is the x and the y squared are going to be flipping spots. Now, a little thing to look for is notice the first letter that you see here, this x squared. This is going to tell me that my hyperbola graph is going to touch the x-axis, or it's going to transverse this x-axis. So it's going across the x-axis. When the y squared is first, then notice your hyperbola is going to touch the y-axis. When we do these questions, we're going to be finding the vertices, the foci, the asymptotes, and then finally, once we get those asymptotes on our graph, we will be graphing the hyperbola. Only thing, the specific point I'm going to look for with your hyperbola is going to be the vertex or the vertices, and then from there, we're going to use the asymptotes as our guidelines. Now, these first two standard form here are when the center is at the origin. We're also going to cover some examples when the center is not at 0, 0, not at the origin. And again, we're going to pull in that order pair, and we're going to use H and K for the center point. That is the same information. I've just rewritten it by hand. Again, the a squared is always first. It's always under the first fraction. And also another key difference is this time the formula to find c squared is equal to a squared plus b squared. When we did the ellipse, it was a squared minus b squared. So just realize that your plus and minus signs are switching. So in the ellipse, the plus sign's in the equation, and the minus sign's in the c squared equals a squared minus b squared, and here it's backwards. To find the equation of your asymptotes, once you square root this a and this b squared, then you're going to put it into b over a. That's when the x squared is first. And the asymptote equation when the y squared is first would be a over b. And it's plus minus because they're two linear equations. So let's go ahead and try an example. Again, we're going to be given an equation. It will not be in standard form. We will need to transform it first by dividing. And then from there, we are going to calculate the vertices, the center, the foci, and the asymptotes, and then finally the hyperbola. So let's try the first example. Again, standard form, I need to set this equation equal to 1. So in order to accomplish that, I'm going to divide everything by 16. So I'm going to simplify the first fraction. 4 over 16 is 1/4. So I can reduce this to x squared over 4. The next one does not need to be simplified. So I'm going to leave it as y squared over 16. And then 16 over 16 is 1. I'm going to find the center. I'm going to also find my a squared value and my b squared value. So again, when there is no h and k, when there's nothing being added or subtracted to your x and your y, the center is going to be at the origin. So my center point is at 0, 0. Again, remember a squared is always first. So a squared equals 4. And a is equal to, I would square root that 4. So it's plus and minus 2. The b squared is second. So that will be equal to 16. And b is equal to plus and minus 4. The formula to find c squared, for the hyperbola, it's c squared is equal to a squared plus b squared. So those two things that I pulled from the bottom of the fraction, 4 plus 16, so c squared is equal to 20. I do need to square root it. When you're writing the equation, you don't need to, but when we're trying to find focus points, we do need to square root it. So it becomes plus and minus the square root of 20. I can also simplify that radical and make it plus and minus 2 square root 5. I now need to find the vertices. The way that I'm going to find the vertices is I'm going to take my center point and I'm going to add and subtract my a value. And the number that I'm going to add it and subtract it to is going to be whatever letter here is first. That's where I add and subtract the a. So I'm going to add it to the x of the center. If the y squared were first, then I'd add and subtract the a to the y. So my vertices are going to occur at plus and minus 2, 0. So if you want to write them as two individual order pairs, you can, or you can leave it as the plus minus. This is where the vertices of my hyperbolas are going to be located. The next thing I need to find are the focus points, or the foci. I'm going to do exactly the same thing. I'm going to use my center point, but now instead of adding and subtracting the a, I add and subtract the c. And again, it's being added and subtracted to the same coordinate, so it's the same, I'm adding it to the x. So I'm going to end up with 2 root 5 plus minus, 0. So again, if you want to pull them apart, you can. And these are the foci. Yes?
Is there a major axis for these?
No.
Okay. So you're always adding like the a and c to the x?
Yes.
Okay.
Well, if the x squared is written first.
Okay.
If the y squared were the first letter you see, then you would add and subtract to the y.
Okay.
That make sense?
Yeah.
Because sometimes the hyperbola looks like the u and the upside down u, and then sometimes the c and the backward c.
Oh, okay.
Okay, so now I need to find the asymptotes. So again, when the x squared is written first, the formula for the asymptotes is y equals b over a x, and it's plus minus. So this is when the x squared is first. So my asymptotes here, my b value is 4 and my a value is 2. So plus and minus 4 over 2. So y equals, I can simplify that to 2x. So the two linear equations that I'm going to graph are going to be y equals 2x and y equals negative 2x. Think of y equals mx plus b. I'm going to graph it at the center, which is my y-intercept, and I'm going to rise 2 and run 1. When it's negative, again, I'll go down 2 and over 1. I'm graphing these two lines for my asymptotes. So I'm going to graph those first. So when you're given a question like this, and this may be the question you'll get on Thursday, it's going to ask you to transform it into standard form. It's going to ask you to identify the vertices. It's going to ask you to identify the foci. And then it's also going to ask you to identify the asymptotes. And then take all of that information and graph it. So let's go ahead and graph this. I'm going to graph the asymptotes first. First thing I'm going to graph is the center point. And from this center point, I'm going to move my slope. and my slope was 2 over 1. So I'm going to rise 2 and run 1. I can do that in all 4 directions because I could continue down my line. So here's my positive y equals 2x asymptote, and then the y equals negative 2x would be this way. So there are my asymptotes. Next thing I'm going to graph are my vertices. So the ordered pairs are right here. So 2, 0 and negative 2, 0. I'm now going to graph my hyperbolas. Again, when we did the parabolas, remember I made you find another point. All I want you to do here is use the asymptotes as your guide. So just draw it like this. Now, you can also draw a box around your asymptotes here if you want to give you that the x has to go through that rectangle. The last piece I need to graph here is the focus point. So your focus point is right here, and we're going to approximate this. Remember, before we broke down this, it was the square root of 20. Square root of 20 is in between the two perfect squares of 4 and 5, 25 and 16. So I'm going to graph this halfway in between 4 and 5. Again, my graph isn't going by tenths, so just give me an approximate location for this focus point. So 3, 4, 5. So I can put a point about here for a focus. 3, 4, 5, and another point right here. So this is what you will be expected to do if we give you a question like this, where I'm going to ask you to find the vertices, find the focus points, find the asymptotes, and then graph everything. Let's try another one with the center still at 0, 0. Everybody good on example 1? Yes.
If we graph it, we just have to like label where we estimated it.
Yes. What I'm going to look for is what I've put in that red box. I'm probably going to ask you just to list the focus point in simplest radical form. All right, let's try example 2. Again, I need to get this in standard form first. Remember, standard form is always equal to 1. So I'm going to divide everything by 100. Because that'll give me an answer of 1 at the end. I'm going to simplify 25 over 100. And that's going to give me y squared over 4. Here it'll give me x squared over 25. And then finally equals 1. Again, there isn't an h and a k in this problem. So my center point, again, is still at the origin. My a value is always first, my a squared, and it's 4. So a is equal to plus and minus 2. My b value will be second. So b squared is equal to 25. So b is equal to plus and minus 5. To find the c value, I'm going to do c squared is equal to a squared plus b squared. A squared is 4, b squared is 25. Add them. Square root. So c is equal to plus and minus the square root of 29. Next, I need to find my vertices, my focus points, and my asymptotes. So for my vertices, again, you're going to take that a value and you're going to add it to the center. And again, notice the first letter is y squared. So I'm going to add the a to the y and subtract the a. So my new vertices are going to be 0, comma, plus and minus 2. So 0, comma 2 0, comma, -2. Focus points, or foci, we're going to take the C and add it to that center. So this will become 0, comma, plus and minus root 29. So if I break them apart, one gets positive 29, one gets negative 29. Last thing I need to write down is my asymptote. So for the asymptote, again, the y squared is first. So the formula for the asymptote is going to be a over b, x, plus minus. So let's go ahead and plug that in there. So my asymptote is y equals plus and minus 2 over 5x. So I'm going to graph the equation y equals 2/5 x and y equals -2 over 5x. Again, I'm going to just rise and run. I'm going to rise 2, run 5 from the center point, which is 0, 0. So let's graph the asymptotes first. So I'm going to start at 0, 0. And from 0, 0, I'm rising 2 and running 5. And I can go down and over. So this is the equation of y equals 2 over 5x. Then I'll do the same thing for the -2 over 5x. Instead, I could go down 2 into the right 5 or up 2 into the left 5. Either way, I get enough points to create my line. These are the asymptotes. All right, next let's get the vertices on here. So my vertices are occurring at 0, 2 and 0, -2. So I'll put them right here on the y-axis, because again, remember the y squared was first. So remember your hyperbola is going to go along, or it's going to cross the y-axis. Last thing I need to include is the focus. So again, square root of 29, that's in between 25 and 36, so in between 5 and 6. So let me add a couple more marks here. So 3, 4, 5, 6. Put it in between there. 3, 4, 5, 6. Put it in between there. And that is the graph of the hyperbola with the center at the origin, or 0, 0. Now we're going to switch and do 2 examples when the center is now shifted and it's no longer at the origin. And again, we're bringing back our HK ordered pair. So here is the 2 standard forms. Again, this one is crossing the x-axis because the x is first. This one would cross the y-axis. But again, our center will not be the origin. It's going to be another order pair. The asymptote, notice these are in point slope form. The y1 and the x1 are actually your h and k. So once you find the center point, that's the point that we're going to move from the slope. It's still the same. The only difference is before we started at 0, 0. Now we're just going to start at a different order pair, but we're still just going to move this slope. We're still going to rise and run. So let's try an example. Now, this one's already in standard form for me. Notice it's already equal to 1. So let's go ahead and find our center point, our A value, and our B value. So again, remember the K is always with the Y. The H is with the X. So we want to list the ordered pair as H and K. Again, it's opposite of what you would think. So -3, -2 is my center point. I'm pulling these out with opposite signs. The H is with the X, the K is with the Y. The next thing I need to figure out is my A value. Remember, A squared is always first, so A squared is equal to 9. So A will be equal to plus and minus 3. My B value is second, so B squared equals 4. So B equals plus and minus 2. To find C squared, C squared is equal to A squared plus B squared. So C squared is equal to 9 plus 4, which is 13. So C will be equal to plus and minus the square root of 13. Let's now calculate the vertices. Now, before it was easy because we were adding that A value to a 0. So to find the vertices, I'm going to add the A value to my center, and the number in the center point, I'm adding it to the Y because the Y occurs first. So I'm going to take -3, comma, -2, and I'm adding 3, and I'm also subtracting 3. So the coordinates for my vertices are going to be -3, comma, 1, and -3, comma, -5. These are going to be my vertices. Going to do the same thing for the foci, but instead of adding the A, I add the C, add and subtract the C. So again, still to the center, so -3, and then comma -2 plus the square root of 13, and -3, comma -2 minus the square root of 13. And those are your foci. We need to find the asymptote. So for the asymptotes, I'm going to use point slope this time. So again, we're using the center point. So we're going to do Y plus 2. The Y squared is first, so I'm going to do A over B. So I'm doing 3 over 2. And then X plus 3. I'm going to leave it in standard form because remember, all we need to do is graph this center point, and then we're going to move this slope. We're going to rise and run from the center to create our asymptotes. So I'm going to graph the center, which is at -3, -2. And then from there, I'm going to rise 3 and run 2. And then I can also go down 3 and get more points on here. So here is my first asymptote. And then I can go in the other direction. Rise 3, run 2, go down 3 and over 2, and again connect the points. Here's your asymptote. So graph the vertices next. They were at 3 and 1, -3, +1, and -3, -5. Again, if you want to draw a rectangle connecting these 4 points, notice how the vertices sit on the edge of that box. Again, use the asymptotes as your guide. and again, throw in the focus point. So again, we can approximate the square root of 13. Square root of 13 would be between 9 and 16, which is 3 and 4. So let's say we approximate it to about 3.5. So if I just graph this one, and I do -2 plus 3.5, if I'm using that for the square root of 13, I would get about 1.5. So a little bit over my vertices, so really close to it. And then I could just put the other one that's equidistant and throw your focus points up there. Again, what I'd be more interested in seeing is this calculation that you got in the red box. Okay, one more example. Again, the center is going to be at HK. So my center is going to be +3, +2. Does anybody know what my a squared value is? 1. Very nice. Okay, so we could add a 1 to the bottom of this, and my a squared value is 1. So if there's not a denominator, know that that denominator needs to be an assumed 1. So a squared is 1, so is a now. A is plus and minus 1. My b squared value is the 9. So b is equal to plus and minus 3. To find c squared, remember you're adding a squared plus b squared equals 1 plus 9. So c squared equals 10. So c is equal to plus and minus square root 10. Again, remember your vertices are off the center. Notice the first letter you're seeing is the x squared. So that's what I'm adding the a and subtracting the a to. So my vertices are going to be 3 plus 1, comma 2, and 3 minus 1, comma 2. So 4, comma 2, and 2, comma 2. These are my vertices. I'm going to do the same thing with the foci. Instead of adding the a, I add the c. So for the foci, I'm going to do 3 plus square root 10, comma 2, and 3 minus the square root of 10, comma 2. I now need to calculate the asymptotes. Again, I'm using point slope.
Why do you do that?
What?
Use point slope.
Because my center, I need to graph it based off the center point. So I need to use the HK as my X1, Y1.
Oh, okay.
Before, when the center was at 0, 0, I didn't need point slope because it was 0. Does that make sense?
Yeah.
Okay, so let's go ahead and take into consideration my center. So it's going to be y minus 2. And again, the x squared is first. So I'm going to do b over a. So 3 over 1. And then x minus 3. So again, don't worry about putting it into slope-intercept form. Graph the center point and then move this slope as your rise and run. So let's graph the center. It's at the ordered pair 3, 2. And then from that 3, 2, I'm going to rise 3 and run 1. I can connect my points. This is my first asymptote. And now I can do the negative. 3 over 1. So up, so go down 3. And again, connect your points. Here's your asymptotes. Again, if you want to make a box around it, you can. You don't have to. Graph your vertices. Remember they were 4, 2. Actually, my boxes are off a little bit. Let me get rid of that box. So 1, 2, 3, 4, 2. And then 2, 2. And again, use the asymptotes as your guide. And again, we're going to approximate that focus. So the square root of 10 is in between 9 and 16, closer to 3. So I'm going to say it's probably maybe about 3.2, 3.1, something like that. So if I go ahead and calculate, say, this order pair, the 3 plus root 10, 2, this would say it's probably about 6.2, 2. So 1, 2, 3, 4, 5. I can put a 6 here and say my focus might be about here. And then I can do the same thing over here. Make it about the same space away. Because if I do 3 minus 3.2, I would get about 0.2, 2. So really, maybe even closer to the y-axis. But again, approximate it. So again, these problems are going to take a little bit of time. Again, we may give you a hyperbola, a parabola, and you'll have to put it in standard form first, and then come up with either vertices, focus points. If it's a parabola, you'd have to find the directrix. If it were an ellipse, you'd find the major axis, the minor axis, the co-vertices. So it's going to depend on the conic you're given. So again, your homework for this is on the slide. Again, I moved the due date till Thursday. Again, there's only 6 problems, I believe, and again, they're going to take a little bit of time. So I highly suggest you start them tonight, and that way if you're struggling, I can do a few more examples for you tomorrow. But if we're not struggling, we're going to move on to writing the equations, which is the same thing we did yesterday. So that is it for the hyperbolas, or day 1 of hyperbolas.